Hello everyone, this is Jimmy Cultist, here today to show you how to make a simple helicopter. Now this video is slightly more complex than my usual fare, so I have a diagram and an exemplar in the background, as you can see. To start with, you make your basic helicopter sculpt, then you make the prop propeller, connect it with a connector, make it a motor bolt, set it to 250 cycles per minute, maximum motor strength, and that should do it for the helicopter's sculpt. Oh, one other thing, set the sculpt to non-collidable. Then stamp out a brick of material and group it with the prop and the rest of the helicopter. Now this is going to act as the actual collision for the helicopter. Simply put 2 bricks here to stand in for the landing gear, and 1 here to act as the center of movement. Then, when you're done with grouping them all, stamp out a little microchip onto this little thing here, and we'll get down to work. You're going to need a controller sensor. And I've got these text displayers for the control scheme of the helicopter, which will come into play later. Now let's just stamp out 2 nodes. And we're going to go ahead and take left stick local and right stick local and attach them to the nodes such. Crisscross. Now we're going to take out a gyroscope, which will keep our copter steady, or at least the main bulk of the copter. It won't keep the sculpt steady, but it will keep the brick steady. Set it to maximum strength, maximum overall dampening, 180 speed, and we're ready. Next, we'll need a camera pointer for our camera, although I suppose you could always just attach a camera. This way seems to work. Hopefully we've got it in the right position. Let's give it a little test. Yes, that seems to work perfectly. Now that that's done, we're going to get down to the movement controls, and this can be a little bit tricky. First thing I want you to do is stamp out a splitter. Connect the node to the splitter's input. You'll see this X output and Y output. Now we're going to start with how the helicopter goes up and down, or gains altitude and descends, so to speak. So, just put this out here like that. And we take out a splitter once again, connect this Y output to the splitter, then take a combiner and crisscross these wires like so. Now that that's done, take out a mover, set it to local space, maximum overall dampening, and maximum movement strength. Set the speed to 0.3 and make it face upward like so. Now using these splitters, as I have just demonstrated, and this combiner, actually it's 3.0, But using these, connecting them to the forward speed, you can actually reverse the speed to -3, making it go down as well as up with just a combiner, splitter, and another splitter connected to this right stick local. Now that that's done, let's give it a little test and see if we can climb. Yes, we can, and we can go down. Perfect. Now that we're done with that, let's move on to another one. Let's do the copter's left and right, or I should say strafe. The copter's strafe will be next. Take out another splitter and connect the left stick local to this node. Connect the node to the splitter. Now that that's done, just label our microchip. Take out another splitter, and this will be mostly the same as the last time we did it. Take the X output from that splitter and connect it to this one. Now, something that's going to be slightly different from before is these wires are going to be connected parallel rather than crisscross as they were before. Now, copy out this mover and just connect this to the speed. Minor modification to the dampening, 21%. Minor modification to the speed, 0.4. Although this is something you could mess around with. You don't necessarily have to do that, but it's how I chose to make my particular copter. Now just face this in that direction. And we'll do a little animation. Scope in, grab the main sculpt of the helicopter, and tilt it a little bit for that strafing motion. Now take both these animations and set the slow power up speed to 0.4 and the slow power down speed to 0.4 as well. Disconnect these wires. Let's go up a bit, and you can see that we can strafe left to right. Now that that's done, let's take out another one, another microchip, and we'll do the forward and backward speed. Take out another splitter, take out another combiner, just as before. Take the Y output from this splitter and connect it to this one. And we're going to crisscross the wires again. Simply copy out this mover. There's no need to modify any of these settings. The only thing we're going to change is the direction. I'm going to set it to forward. Connect this here. And add a little animation for that extra flare. Tip it forward. Probably use precise move for this. And another one. So when the copter goes in reverse, it tips backwards. Let's give it a little test. Alright, those animations are not properly connected. Just crisscross them like so. We could also turn down the speed. Just to be clear, connect plus to this one and minus to that one. Or I suppose you could turn them around to make it easier. Now, we're going to turn up this, turn up that. Nice forward and backward movement. Strafing. I may have made a slight error on the control scheme. We're actually using the left stick to strafe right and left, and not the right stick as it's displayed there. A minor error on my part. Not exactly sure how that happened, but it's not a major catastrophe. Now, finally, the last one will be the turning. For this, we're going to be doing something relatively similar to the examples before. Crisscross the wires. And we're going to be taking out a mover with the same settings as before. And it will be facing exactly that direction. The only minor difference that we're going to have this time is we're going to employ a rotator. Set this little thing upright. Set maximum rotation strength, maximum overall dampening, and set the speed to 50. Now we're going to add some animations. These should do nicely. We'll just reuse them, and we'll figure out which ones connect to where. For now, we're going to try the crisscross methodology. We're turning. As you can see there, we have a full range of movement. Forward, backward, up, down, right, left strafing, and a turn. Now, that's actually all there is to it. If you found this video helpful and you enjoy logical insights from EDC, don't forget to like and subscribe. Maybe leave a comment on what you'd like to see in future. I myself may be producing a wall climbing tutorial in the near future. But until then, that's all for now. Have a nice day.